In this video, we will discuss graphing quadratic equations. Let's first give a general description of the graph of y equal ax squared plus bx plus c. The graph of a quadratic equation is a parabola. A parabola is a special bowl-shaped or U-shaped curve in the xy plane. One description of a parabola is the set of all points that are equidistant from a fixed point called the focus and a fixed line called the directrix. This diagram shows a generic parabola. Notice the focus and the directrix. Each point on the parabola is located at an equal distance from the focus and directrix. Other features of interest are the vertex, where the graph changes direction, and the axis of symmetry that splits the parabola into mirror images. The vertex and the axis of symmetry are useful in graphing parabolas. We've already stated that the graph of a quadratic equation y equal ax squared plus bx plus c is a parabola. To determine whether the parabola opens upwards or downwards, we consider the sign of the leading coefficient a. When a is positive, the parabola opens upwards. When a is negative, the parabola opens downwards. The illustration shows an upward opening parabola and a downwards opening parabola. Each parabola has an axis of symmetry and a vertex. Given the equation ax squared plus bx plus c, we can find the axis of symmetry and the vertex. The vertical axis of symmetry has equation x equals minus b over 2a, and also the vertex has first coordinate x equal minus b over 2a. To illustrate, again consider a generic parabola. The vertical axis of symmetry has equation x equal minus b over 2a. Since the vertex, hk, is on the same line of symmetry, it has the same x-coordinate. We will present a set of general guidelines for graphing quadratic equations, followed by two specific examples. First, use the sign of the leading coefficient a to determine whether the parabola opens upward or downwards. Find the y-intercept. Find the vertex, and find any x-intercepts. We will actually find these points in any convenient order. Sometimes the y-intercept is easiest to find, sometimes the vertex or x-intercepts are easier to find. Then plot the points and draw the graph. To illustrate, we have a set of axes and a coordinate grid. Plot the y-intercept, plot the vertex, plot any x-intercepts, and then sketch the parabola. For example, let's sketch the graph of y equal x squared minus 8x plus 12. The parabola opens upwards since a equal 1 is positive. The y-intercept is the point 0, 12. The vertex has first coordinate x equal minus b over 2a, which is minus negative 8 over 2, which is 4. To find the y-coordinate of the vertex, we plug x equal 4 into the equation and get y equal negative 4. Therefore, the vertex is the point 4, negative 4. To find any x-intercepts, we solve the equation y equals 0. We have a quadratic equation to solve. Fortunately, the quadratic expression factors, producing a product equal to 0. Therefore, one of the factors must be 0, and we get that x equals 0 or x equals 2. Thus, the x-intercepts are the points 2, 0, and 6, 0. In our solution, we repeat what we just found to have a list of conveniently accessible points. And then we can draw the graph. We need coordinate axes and a grid to include the x and y values that cover our given points with a little extra space. I've used the interval from -2 to 8 on the x-axis and the interval from -5 to 14 on the y-axis. I'm going to plot the y-intercept, 0, 12, plot the vertex, 4, -4, plot our x-intercepts at 2, 0, and 6, 0, and then sketch the parabola. Remember that scale matters in graphing. If you graph by hand, make sure you are being consistent in your spacing on the axes. Quadratic equations may be given or put in other forms. One particularly convenient form is what is sometimes called vertex form. The graph of y equal a times the quantity x minus h squared plus k will be a parabola with axis of symmetry x equals h and vertex hk. Looking at this new formula, it's helpful to make a few comments. First, the leading coefficient a is the same a value appearing in both forms of the quadratic equation. Next, notice that the vertex form of the quadratic equation has a minus h and a plus k. We could be given an equation already in vertex form, or we might put our equation in vertex form by completing the square. How this is done is the topic of the next video. For now, let's consider graphing a quadratic equation that is given in vertex form. In particular, let's graph y equal -2 times the quantity x plus 1 squared plus 3. Since a equal -2, the parabola opens downward. We can read the vertex hk right off of the formula. The vertex is -1, 3. We have to work a little bit to find the y-intercept. Plug x equals 0 into the formula, and we get that y equals -2 times 1 squared plus 3, which equals 1. So the y-intercept is the point 0, 1. To find any x-intercepts, we set y equal to 0. Thus we have -2 times the quantity x plus 1 squared plus 3 equals 0. We could subtract 3 from both sides of the equation and then divide both sides by -3. Next, we could take the square root of both sides of the equation and simplify by rationalizing the denominator. Finally, subtract 1 from both sides, getting a common denominator to add the fractions on the right-hand side. Our x-intercepts are irrational in this problem. This is a relatively common occurrence. Here's a summary of what we have so far. A down parabola with vertex at -1, 3, y-intercept at 0, 1, and irrational x-intercepts. To graph, it might be useful to approximate our irrational x-intercepts. We need coordinate axes and a grid to include the x and y values that cover our given points with a little extra space. I've used the interval from -3 to 2 on the x-axis and -5 to 5 on the y-axis because we have a down parabola. We're going to plot our y-intercept at 0, 1, the vertex at -1, 3, plot our approximate x-intercepts, and finally sketch the parabola. Again, if you're graphing by hand, make sure you are consistent in your spacing on the axes.